Hello, I'm Stephen Foskett. Welcome to the second session of the Virtual Symposium here with Brocade. We are going to record 4 different sessions. We talked originally about fabrics generally, multi-chassis MLAG, and hard cores and soft edges. Now we're going to be talking a little bit about something that's important to me as a storage guy, and that's converged storage networking. So again, there are other videos out there as well that you can find at techfieldday.com, among other places. But let's just kick it all off. Again, I'm Stephen Foskett. You can find me on Twitter at @sfoskett, and my blog is blog.fosketts.net. Please, Josh.
I'm Josh O'Brien. I blog at staticnat.com, and I can be found on Twitter at Josh O'Brien77.
Hi, I'm Chip Copper from Brocade, chip at brocade.com.
I'm Tony Bourke, datacenteroverlords.com, and I'm on Twitter at tbourke, TBOURKE.
Right. So now, convergence is important to me, and this is actually a topic that I speak at my seminars. It makes sense. Convergence has always made sense, but it has never worked. And you know, I was systems administrator in the 90s. There was a lot of talk about convergence on ATM. There was talk about convergence on Fibre Channel originally. You know, I mean, remember IP on Fibre Channel and all that. Why is it this time for sure? Why does it work this time and it didn't work in the past?
I think the thing is that up till this point, no one has said this time for sure. That one of the things that's come out is not necessarily that we're strong proponents or we necessarily see everything going to convergence, but rather we're now deploying a single network that's capable of handling storage traffic, TCP/IP traffic, lossless traffic, lossy traffic, and so the capability is going to be there inside the network as soon as you wire it the first time. And I think that's a little bit different because one of the things that we'd seen happen is at the very beginning of all this, Fibre Channel over Ethernet was just starting to emerge, and people were very excited about Fibre Channel over Ethernet, and the world is going to Fibre Channel over Ethernet, and that's what we're going to see, and Fibre Channel is dead, along with Fibre Channel. So what happened instead is we started to deploy Fibre Channel over Ethernet, and people started to get a feeling for what was going on, and all of a sudden they started to say, you know what? I may have partial convergence, but I've got too big of an investment in Fibre Channel, or there are some things that I don't like about convergence. For example, I have the IP traffic, the administrative traffic, and the storage traffic all competing for the same bandwidth. The biggest thing that's stopping convergence, I'm sort of taking the opposite side of where it was, the biggest thing that's stopping it right now is actually organizational. Because it turns out that pre-convergence, I would have, for example, and I'll even try to remove Fibre Channel as much as I can as a point technology, I would have a storage network and a TCP/IP network. Now, in many cases, there was actually one vendor who said a SAN is, in fact, an iSCSI network. And so what they advocated was not convergence, but to have a completely separate IP infrastructure, Ethernet infrastructure, running iSCSI storage, and that was the best practice. So that's what they recommended on the back end. But when we have those two different organizations, we also happen to have two different domains of management. And so, for example, the networking people would manage the TCP/IP network, the storage people would manage the storage network. Well, now when I start to get into convergence, I start to get into some really dicey issues, especially with Fibre Channel over Ethernet. Suppose, for example, I have IP traffic and FCoE traffic that goes through a single switch. Typically in the Fibre Channel world, when we come out with a new version of firmware, one of the things that we're told by customers over and over again is, I don't want new versions of firmware. I can put one, maybe two versions out.
Because Fibre Channel firmwares have always been a nightmare, but
it's a nightmare because of the type of traffic you're handling. Because if this were regular TCP/IP timeout and retransmit, you could do it all the time. The problem is that you expect that reliable, in-order, deterministic behavior of storage traffic. And so what happens is that people say, get it down to maybe one or two versions of firmware a year. But now CERN comes out with an advisory that says, we've discovered a vulnerability. You need to go out and reflash the firmware. So now you've got the storage people saying, don't touch the switch for another 6 months. The IP people saying, we have a fiscal responsibility to go out and update this, and they're converged on the same platform. What do you do? At this point, the biggest barrier that we're seeing to convergence is actually more organizational and responsibility oriented than it is necessarily technology oriented.
There's a lot of barriers, and there's always been a lot of barriers for convergence. Certainly, I agree with you that in terms of responsibility and ownership, that was one of the things that caused iSCSI so much problems. Along with the sort of a prejudice against internet or IP-based protocols and storage, but certainly the idea that we would have an Ethernet network for storage, it's one of those things that's slowed down, NFS and CIFS and SMB all this time. Convergence, the political issue is not going to go away.
That's right.
There are also technical challenges to convergence. When people say convergence, again, the first thing they say, and the first thing you said was FCoE. Convergence doesn't necessarily mean FCoE, and in fact, FCoE is just out of the packaging. We're just still peeling off the white wrappings to see what it looks like underneath. iSCSI, NFS are much more well established and well understood. I'm curious: is there a benefit to going to, using those protocols, and I guess maybe let's bring in everybody else here too, using those alternative storage protocols, obviously FCoE requires, data center bridging protocols, data center bridging, technology. NFS doesn't. iSCSI doesn't. Maybe convergence could mean something else too. What do you think about that?
Converged storage means a win for people who aren't classically storage people. There's this huge market out there, people who are starting to see cost values for virtualization, cost values around VDI. And one of the big holdbacks for them has been, okay, what is the one thing we have to do? We have to bring storage into this. And they're not used to having SANs or big NAS or all these different, pieces of hardware and budget spends. So the last thing they want to do is spin up a dedicated network that, one, they don't understand, that two is extra cost. They've already got this Ethernet infrastructure that in a lot of cases is dramatically underutilized. So in most modern stuff, especially around iSCSI and NFS, we have jumbo frames, we have the capability to just inject these technologies into existing environments and win with them. And converged storage means a lot more to those people, I think, than to the siloed organizations. The siloed organizations are looking at it, cost savings, wire and rack once, never do it again, those type of models. But to be honest, I think FCoE caters to the FC people. It caters to them as a transitionary technology. It's not necessarily this great leap forward. It's putting it over a different media. It's not exactly changing a lot of the rules.
Yeah, and that's so true. That Fibre Channel over Ethernet just swaps out some of the stack of Fibre Channel. I mean, it's very, very similar to Fibre Channel over Fibre Channel.
Yeah, it's managed the same. In the vast majority of Fibre Channel over Ethernet installations right now, it's very popular. It works great. The vast majority of them are edge FCoE deployments. We have a server with a CNA, a converged network adapter, plugging in an Ethernet 10 gig links to an upstream switch. That link runs both Fibre Channel and Ethernet. The server sees...
it runs Ethernet.
Right, yeah. I'm sorry, FCoE.
Yeah.
So the server sees a separate Fibre Channel interface, a native Fibre Channel interface, and a native Ethernet interface on the card, or maybe sometimes in software, but usually on the CNA itself. The Fibre Channel frames get encapsulated into Ethernet frames, send up that link, and that's as long as that FCoE frame lives. Because once it hits that northbound switch, that access layer switch, that switch has a Fibre Channel forwarder, decaps, and then forwards the frames of native Fibre Channel and native Ethernet. And that works right now, and that works great. That's
Absolutely.
Sort of the first
And that's
step.
actually pretty cool, isn't it, to think about it, that nothing is the wiser. The application doesn't know, the operating system doesn't know, the storage array doesn't know. Nobody knows that we're using Fibre Channel over Ethernet.
That access layer switch, it doesn't need to communicate any special protocols other than Ethernet and Fibre Channel. It doesn't need to do DCBX, doesn't need to do ETS or PFC beyond, so ETS enhanced transmission selection, PFC priority flow control. It doesn't need to go beyond that switch. It knows it, but it's contained within that first layer switch.
So the accountants love that, because what the accountants say is, look at all the money we're saving by going to this converged infrastructure. I have fewer cables, I have fewer adapters, I have fewer switches, but realize that the environment from a management viewpoint hasn't gotten simpler. In fact, the environment's gotten more complicated.
It's gotten more complex.
It has, in fact, because now I've got all these different pieces that can mix with each other. So now let's concentrate. I thought you raised a very relevant point, which has to do with IP-based storage. What are we going to do with that? The biggest problem with it is, well, let me start by throwing this out here if you don't mind. Let's talk about lossless Ethernet for a second. That when I've gone in and talked to storage professionals, one of the things they've told me is, we'd like to run NAS and we'd like to run iSCSI, but we want to run it over lossless Ethernet.
And that's actually a really key emerging trend, in fact, for Convergence, is the idea that, you know, wait, you know, I mean, if FCoE demanded all these lossless technologies be added to Ethernet, but man, that's really good stuff. And we could run iSCSI over that, we can run NFS over that, we could run, you know, RDMA over that. There's all sorts of cool things that we can do with this new lossless Ethernet technology. And similarly, the same thing can be said of fabrics. You know, you look at that and you say, wow, that's really cool. I mean, it's cool for iSCSI just like it's cool for FCoE.
That's right. Here's the uncomfortable part. The uncomfortable part is, for me, from Brocade, if you want to run your iSCSI traffic or your NAS traffic over it, we're good with that. We're all set to go. The problem is at the termination points. Because generally what happens is, precisely for the point that you mentioned, there's a fiber channel interface that goes down to a CNA, Converged Network Adapter, and then there's the IP, the NIC looking side. All of the NAS traffic and the iSCSI traffic is going to go down the IP side, which says that by default, it's going to go onto the lossy lanes of the Converged Ethernet. So what that means is, I now have to find someone who's willing to do deep enough packet inspection somewhere, or I'm going to have to change the way that I present NICs up to the operating system so that I can differentiate between, well, do I want this IP stream to be lossless or do I want it to be lossy? And it turns out that I not only have to do that on the host side, I have to do that on the storage side as well. Because now if I've got this particular priority that's arriving, the storage device has to know how to encapsulate that. It turns out that is a sufficiently hard problem that there are just a few vendors that are out there today who are touting a lossless iSCSI or NAS solution, but the way that they've done it is by controlling both the storage side and the host side, because in there they can add their special sauce that goes in through and differentiates these frames. So from the networking side, we've got the easy job. We only have to do the transport.
But let me ask you, in the future, do you think that we're going to go to all lossy, or I'm sorry, all lossless? Do you think that that's just going to be, somebody's going to flip the switch and just say, forget it?
Absolutely not. And one of the reasons I say that is because if you go out and read best practices paper on IP networks, they'll tell you that, especially in wide area networks, but also throughout the campus and so forth, the minute you make IP traffic lossy, or I'm sorry, lossless, everything slows down. Because you almost depend on a certain number of frames getting lost so that I can do things. Recklessly is the wrong word, but what that means is that if I find myself in a tight situation, I don't have to worry about end-to-end congestion notification or flow control. Instead, with comfort, I can say, throw that away, someone's going to retransmit.
It's interesting. In an unlimited bandwidth environment, lossless Ethernet makes total sense, but there's never unlimited bandwidth. 3G is a perfect real-world example of this. 3G isn't a bad protocol, but 3G has all sorts of lossless mechanisms that you can flip on, so your packets never die. They eventually get there, but they're totally immaterial by the time they arrive. And thus we get, you know, ping times that are,
voice traffic
5,000
doesn't need to be
milliseconds
lossless. It should be fairly you know, it can be lossy to a certain point, but it does not need to be lossless. And like a lot of some storage vendors, some NAS storage vendors or iSCSI storage vendors will make you turn on flow control on your upstream IP switch, which is sort of the old-timey version of what we call lossless now. So it's the pause frame. So modern lossless is the PFC, priority flow control. So we can say one of our cause values of Ethernet frames will be lossless, and the rest we can be reckless with.
So I guess shifting gears then. Now that we've kind of answered that question, what about Convergence and DCB? If FCoE is the big driver for the lossless Ethernet storage right now, which is what we just basically said, that's kind of the protocol that's going to go over lossless Ethernet, and if FCoE is generally edge only, what does that mean for Ethernet fabric technology? What does that mean for east-west traffic and things like that? How does that change things?
I think from an IP traffic viewpoint, it won't change anything. But I think that the thing that you really want to watch here is management traffic. For example, there's some things that if you happen to lose them inside of a fabric, they can turn out to be really disastrous. And you touched on the idea of pause frames. And I think this is a significant difference between the way lossless is implemented in the fiber channel world and in the IP world. And if I may, I'd like to, or the Ethernet world, I'd like to chase that for just a few minutes.
That's actually worth talking about because it's a major difference.
Absolutely. In the fiber channel world, the way that it works is you have this idea of a buffer credit. A buffer credit says, I'm going to give you a license to be able to send me one frame. And if I don't give you the license or the token, you can't send me another frame. So the way that I can guarantee lossless behavior is to say that you only send me a frame when I give you a token. If I don't give you a token, you have to sit on that frame because that's how I guarantee that the frame is going to move reliably through the network because I've, in a sense, guaranteed space at every single hop, or it doesn't advance. It never goes beyond where I'm at right now. In a lossy switch environment, and by the way, I have to say this respectfully, lossy is not a bad term. I mean, I've been in several conversations where people say, well, you people think that, you know, your switches are lossless and Ethernet switches are throwing away frames all the time. That doesn't happen. That's not what lossy means.
What does happen, but that's by design.
That's right.
I mean, to a fiber channel person, the idea, I mean, Ethernet switch is a frame murdering machine. But to a networking person, that's fine.
That's exactly right.
And an important distinction with, so in IP and TCP, we have the notion of flow control, but that's handled in the upper layer protocols.
Right.
In fiber channel, flow control, for the most part, there's a couple ways to do it, is on a port per port basis. So the buffer to buffer credits don't happen host to host. They can. Well, not.
They're not end to end.
They're not end to end. They are port to port, one fiber channel port to another fiber channel port, or across the switch's backplane. That's a major architectural consideration for any switch that wants to be lossless, Ethernet or fiber channel, is that backplane from port to port internally needs to also be lossless.
That's right. So now let's look at how it was implemented on the Ethernet when we're going to lossless Ethernet. And again, forgive me for being on a rant, but you'll notice a common rant throughout all this. We've always done it that way before. In the Ethernet world, the way that we've always done it before to enforce frame control is frame control. Whoops, that was a Freudian slip.
Your biases are starting to slip out here.
So the way that it's always worked before is through something called a pause frame. It's important to know how a pause frame works. A pause frame doesn't say stop sending me information. What it actually says is stop sending me information until this much time has gone by. And after that much time has gone by, if you don't hear anything else from me, then you're okay to start sending more frames.
It's not a stop frame, it's a pause frame.
That's right. It just pauses things. So that when they were looking at chopping up the data streams into different pieces using priority flow control, the idea here is that I want to be able to use the pause primitive because I've always used the pause primitive before. And so now what I want to do is if I have traffic that's been designated as being lossless, then it's on one of the lossless priorities. That means that if I start to see a situation where I'm congesting up here or I don't have a space to move the frame, you're not going to send it to me. But the reason you're not going to send it to me is because I send you a pause frame. And this is the difference. I'm going to continue sending a pause frame until you don't hear from me anymore. So it's sort of, in one case, it's very inactive sort of you may now send it, to going to a sort of an almost passive sort of send it unless you hear otherwise.
Well, I may be wrong here, and I'll need to look at the RFC. My understanding, though, was that a pause frame can also be an unpause frame. Is that possible?
Yeah, you can send a shorter pause, right? Or a
yeah, you can send a zero pause.
Okay,
yeah.
So I may have been mistaken here. Is that you can't? I thought you could send a unpause frame. So I send a frame that says start.
I send you a zero pause, and it means you don't have to pause anymore.
Well, yeah. So that would be an unpause frame.
You can do that, but if something goes wrong, or for some reason your pause is delayed, like if the queue has been built up something,
right?
And I don't get that pause frame, I've already sent it, and I've already flushed my buffer.
And that also means a limitation in the distance between lossless Ethernet, because I have a limited buffer. As my buffer fills up, and it's organized into queues, as my buffer fills up, I need enough time to send someone a pause frame so they will stop sending traffic so I can guarantee that losslessness. As the distance in a link increases, the amount of time that I have
to send that pause, and this is something that TCP has had to deal with for a long, long time.
Right. So fiber channel over Ethernet, the PFC, for most vendors, I think the limit is 300 meters. So I can't do like a 12-kilometer lossless link with PFC right now, for most vendors. But it's kind of an emerging standard, and I guess different vendors will handle it differently.
Okay, this is my job. Really, 300 meters is a problem? Talk to your local Brocade team and talk to them about our new enhanced distance limitations
Okay.
for VCS, where you'll find out that we can actually go much farther than that.
Okay.
Measured in terms of kilometers now.
Well,
This commercial brought to you by
Yeah, was that shameless? Was that shameless?
And we've been talking a lot about protocols. We've been talking a lot about the standards that we've been doing to get these converged storage technologies in place. The other thing that we haven't really talked about is the hardware. And the hardware is a huge statement in this because for the longest time, we had all this oversubscription. And oversubscription was just something that we accepted in Ethernet. And it worked out really well from cost models. And the thing that's not playing out so well anymore is this massive oversubscription. Because light buffers, oversubscription, big chassis, all this stuff, we've talked about it, some of the other aspects of this, is the fact that now we're looking about point devices that aren't lossy in their nature of hardware because they're not oversubscribed. They have deep buffers to deal with these storage technologies and the pause frames and all these things. The hardware is a big change too, and we haven't talked a whole lot about it from a hardware raw perspective, but it's just as important as the actual protocol stack in understanding how this technology extends. And I'm guessing that goes into some of your enhanced functionality for distance and stuff. There's got to be a major hardware play tied back to that too.
That's right, and the whole issue of oversubscription comes back. If you look at the Fibre Channel side, we've never had an oversubscribed Fibre Channel switch. The only place where something was oversubscribed is where we came out with a very high port density, in which case, in great big letters, we said, if you install this blade, here is the oversubscription. But even if you look at all of our fixed form factor devices, the small port counts, all completely non-oversubscribed, all the way up through hundreds of ports that, again, completely non-oversubscribed. We're not saying that oversubscription is bad, but we're saying that when a network designer is trying to figure out what makes the most amount of sense, you should be able to say, at least here at the aggregation layer, you know what I mean. You know, in a fabric, that might be something else, but at least at an aggregation layer, and I've got this incredible number of virtual machines that are coming in, I want to make sure that if I populate that with VDI instances or virtual machine, I can give it 100% bandwidth, and the rest of the switching infrastructure is going to be able to handle it.
And I think you hit on a key point, which is design. Because design still matters. Fabrics don't eliminate design. Lossless Ethernet doesn't eliminate design. Just because you can throw all this crap on one wire doesn't mean you can just write off design and good planning and good structures.
And we've been getting away we've been a little bit cheating in a lot of these iSCSI and NFS networks by building a separate air-gapped storage network.
And usually a very simple network. I think regarding design, most of, if they're using a separate air-gapped network, then it's a very simple network. It's only a few switches, and it's not a big, 3-layer core edge Ethernet.
It might be AB with no
a
spanning
switch.
AB and no spanning tree. So it makes it a very easy, very simple, even simpler than Fibre Channel in many respects in that regard. But those are typically 1 gig switches. Now we've got 10 gig. So the benefits of 10 gig in terms of throughput, reduced latency, and all that. Another important consideration is I think we always forget that most of the time our storage arrays are oversubscribed in terms of their ports, because we'll have 100 servers connecting to 10 ports on
oversubscription may not be the good right word for that. We call it fan out.
Fan out, there we go.
Yeah. So there is restrictions.
Yeah.
Fan out, fan in, whatever.
That's right.
Yeah, and actually, to that point, another thing that I think a lot of network guys don't realize is that no storage array can operate at wire speed when you're talking about these super fast protocols. So,
right.
And actually, one of the things that Greg Farrell brought up recently was the concept of what does SSD do to the topic of convergence, and it actually makes a huge difference, because think about it, SSD for the first time, well, not for the first time, but for the first time, the mainstream has technology that can actually keep up with 10 gig Ethernet or 16 gig Fibre Channel. And we just didn't have that before. I mean, we could do that in little bursts when it was in the cache, or we could spend tons of money with DRAM arrays. But now we have mainstream arrays that can actually fill a 10 gig pipe, and that's amazing.
And there's a big difference in terms of a networker. Networkers tend to think of networks in terms of throughput.
Mm-hmm.
In storage, we have to have an additional consideration. We need enough throughput, we need enough capacity, bandwidth, but another huge issue is IOPS.
Yeah.
And latency, and being able to do...
Yeah, and there again, an SSD or any kind of solid state array, whether it's DRAM or flash, it can deliver just crazy IOPS.
Right.
I mean, I don't want to say an average array can do this, but many vendors now sell a storage array that can deliver all the IOPS of a data center in one storage array going down one port.
Yeah, so
that's terrifying.
So yeah, vendors like SolidFire and Pure Storage and Violin.
I could go on and on. Yeah. There are many of them.
Yeah, like have arrays.
And in fact, we have a solid state storage symposium next week. Yeah.
I have like a six
fun, isn't it?
in 6 RUs. I've got 300,000 IOPS. That would take 3 racks of spinning Rust, short stroked and all everything just to get that.
Yeah, and some of them can deliver millions of IOPS. Yeah. So enjoy.
So now what I want to do is, if I might, for just a second, is I want to talk about the role of fabrics in all this. Because, so we've talked about lossless behavior, we've talked about storage traffic. What does fabric do for you in this situation? I think, as we talked about in another session, the idea of the fabric is that as we start to expand things, we eliminate this idea of saying, I'm going to go up before I come back down. Now, I want you to imagine a deployment of virtual machines where, for example, I've decided to have my servers and my storage in exactly the same rack. And things are going well, but what I've discovered here is that now it's time for this storage array to be accessed by another set of virtual machines because I need to scale the application, but I'm going against the same data set. So now I add another rack beside it, and that rack beside it is now going to have another traditional access switch. What does it need to do? Traditional networking says, well, if it's not going to the same access switch, it goes up and then it comes back down. Which means that now I'm going to start adding to the original traffic flow, storage traffic flow. In a fabric environment, what I can do is I can take those 2 switches that are in the top of those racks and I just hook them together. Now, if the regular traffic was going outside, if this is north-south traffic, it's going to continue to use the same paths that it was before. But now with the fabric, I've got a way to hop directly over to that local storage array as well as manage any emerging east-west traffic, and I haven't violated any of the rules of spanning tree because there is no spanning tree, that now I'm able to take advantage of the ports that are out there. So now I can start to build up my virtual machine environment. I can decide where it makes sense to deploy that NAS storage, and I don't put myself in a corner by saying, I put it in the wrong place, it's on the wrong side of that AG switch, or it's coming in on the wrong access layer. In this case, I can plug it in wherever it makes sense because it's now a cloud, and it's going to find the shortest path.
Would a part of the fabrics, especially a converged fabric, would a part of a converged fabric a necessity of being able to do things like ETS, enhanced transmission selection, so that I can guarantee storage a certain amount of every one of those links? Because otherwise I can flood out, if I do a lot of eMotion traffic, I could potentially flood those links. I want to make sure that I'm not starving out data traffic or storage traffic.
That's right. According to industry standards or best practices or whatever the right code word here is, that today IP traffic, it tends to be relocated to the same ETS group, which basically says that's how much bandwidth you get because I'm reserving some bandwidth, well actually highest priority for fabric events, fabric traffic, and then another slice in another priority group for lossless fiber channel over Ethernet. So to do that, by the way, I think it's an outstanding idea, but again, I can say it's an outstanding idea because I sit in the easy chair of saying all I have to do is pass the traffic. The difficult lift there is going to be going back to the storage vendors and go back to the host vendors and have them separate that traffic at some point further up so that now it's put into 2 different classes of traffic so I can put it in 2 different enhanced transmission selection groups. That's the tough part. And that's where, once again, we can certainly support it. I mean, we'll certainly advocate it. But it turns out that part of the data center bridging protocol, DCBX, when 2 things start to talk to each other, they begin by negotiating. And part of the negotiation says, here's the kind of traffic I'm putting in each group, and here's the ETS different shapes that I'm using, and here are the different priority classes. They all have to agree on that. So what that means now is a massive reconfiguration or what are best practices to separate that traffic.
So if you're not familiar, ETS is a part of the data center bridging standard. So data center bridging is a collection of standards. The most important ones, I think, were probably PFC, priority flow control, which gives us the losslessness in Ethernet without making everything lossless. And then ETS, enhanced transmission selection, which allows us to say storage traffic gets X amount of bandwidth or percentage of bandwidth, etc.
That's right. That's exactly right. There's one more piece that I have to talk about. Oh, how come I always have to tell the scary stories? Here's the scary story from a storage viewpoint. It turns out there's another piece that's not done yet, at least at the time that we're taping this, and that's something called congestion notification. Here's what congestion notification says. This is actually kind of cool because it's something we're all familiar with. If you go to get on an interstate and downtown everything is all jammed up, they turn on metering at the edges. So now as you come up the off-ramp, you have to sit there and waiting for your turn for the red light to turn green, and then you shoot through and everything. And the reason for that is by throttling the input to the interstate, they hope to clear the congestion downtown so that by the time you get there, things will be moving more smoothly. Lossless Ethernet has that same concept. The idea that basically says, as I start to see congestion down here, I'm going to go back and I'm going to notify the ingress points of that congestion and have them throttle traffic coming in. Here's the problem, and I'm a mathematician, by the way, so I love the original proposal, because what it did is you would go in and you would look at the slope of traffic and queue lengths and trending information and so forth, and then based on that, you would shoot frames back upstream to get to the source to have them do this. So mathematically, it was beautiful, absolutely eloquent. And then you turn it over to the engineers and they'll say, okay, just to recap here, on all of these different switches, you basically want us to perform differential calculus and solve a set of equations to determine the instantaneous slope of the rate of traffic coming in from these points and notify it. And the mathematicians said, exactly. And the engineers said, no, go work on something else. So now we find ourselves where we don't have that end-to-end congestion notification yet. From a storage viewpoint, that is of concern, because that means as we start to scale the network to any reasonable size, I mean very large size, that means that I'm now going to have congestion here because of something called, I guess I can call it a slow draining device. Today, people don't like to say slow draining device because for the points that you mentioned, that implies the storage arrays can't keep up. And so we have to use other like nicer code words like bottleneck detection or something like that. But what it amounts to is that if we're doing something like that, we're only going to bog down the network by allowing these lossless frames to come in. And so what we need to do to really complete this is we need to have an end-to-end signaling mechanism in a standards-based way so that now if traffic is jammed up down here, I can tell the host to slow down. The fiber channel world, we have that. It's called ingress rate limiting. The problem is in the open standards world, CN didn't go through yet. So what that means is that vendors like Brocade and the others who are out there need to deal with this, and so I have to say the P word. Because we realize it's so important, we deal with it in a proprietary fashion, but that also does something now for the interoperability of all these switches. The reason they're not interoperable is because we're trying to be mean. The reason they're not interoperable is because the standard isn't done. But yet, Fibre Channel over Ethernet and Converged networks, as you know right now, is a little bit of a land grab. That all the major networking vendors are out there saying, we've got a solution, buy this, buy this, buy this. Now the thing that we have done is we've made sure that according to what everyone agrees, the frame formats and the protocol signaling that needs to be done is already built into our silicon. It's just a matter of putting the firmware to enforce the protocol, just as we talked about with FSPF. But it's in there. And we're very anxious to see that end-to-end notification come in precisely because of IP-based storage.
So one thing that I'm curious about, I've not seen yet because it's fairly new. We have not really deployed, with the exception of some FCoE installations, we have not really deployed as an industry lossless Ethernet for iSCSI or for NFS. So what I'd be curious is what is the performance benefit? If I run an iSCSI array and a bunch of nodes, or I run an NFS array, if I turn on losslessness end to end, what's the performance boost going to be? Is it going to be 10%, 20%? I'd be curious, and I don't think we've seen that just yet.
I have a quick answer to that. It turns out one vendor has done that, and I don't know if I'm allowed to say who it is or not. So go out and grep it, and you're going to find it. No, grep it. I'm sorry.
I want to create a new search engine called grep.
I get some points for that, though, right? Didn't I? For saying an old guy thing.
That's a cred. Yeah.
Go out, and what you'll find out is that one vendor has done that, but they did it primarily for the traffic isolation, not for the performance.
Okay.
So, convergence is certainly coming, but it's probably not come. And it's one of those things, again, as I said at the start, we've been trying to converge for a long time. Perhaps this time it will work. Ethernet is perhaps not the ideal platform for DMA and for SCSI frames, but that's what we got. So we're going to have to try to do as good as we can. with what we have, and so it's good to see so much development happening. Certainly, I think everybody should know that, as you point out, there are functioning implementations of Fibre Channel over Ethernet, of lossless Ethernet, Fibre Channel or Ethernet fabrics. There are, and people can deploy them, and they do work. But we're going to see some really cool stuff happen in the future as those things become a little bit more standard, a little bit more interoperable.
And we're learning.
And we're exactly. We're learning what the implications are. I mean, there are so many implications. Like you say, with the slow drain problem, that has serious implications for convergence and success of convergence projects. We don't have to worry about that so much if Fibre Channel over Ethernet is edge only,
right?
Because it just kind of works. But once we get into, and you've written about this, I know, once we get into full FCoE, SANs, we're going to start finding all sorts of exciting new things that have been discovered and dealt with in Fibre Channel over the last 15 years. So thank you for going through this.
Thank you.